And you are of course most welcome. This is Project Euler problem number 19. Very simple brief. How many Sundays fell on the first of the month during the 20th century? Really simple. So there is of course a brute force solution and an elegant solution, and I will take you through both. The brute force solution is actually quite interesting because it allows us to use Python's date time module, and also we're going to meet something called a generator. Now I expect some of you know what a generator is, but some of you might not. So let's import the datetime function. How this is going to work is essentially we're going to go through every day in the 20th century in order. We're going to see, was it the first of the month and was it a Sunday? Okay. Now, a generator is a special type of function. A function takes an input, it does a bunch of stuff to it, and then it produces an output, and it does all this in one go. You might not always want it to do that. Sometimes you might want it to do one iteration and then produce an output, and then do another iteration, produce an output, do another iteration, produce an output. And that's exactly what a generator does. So instead of just doing the whole lot in one go, it'll give you bits at a time, and then you tell it when to go and get the next bit. So it'll become clearer in a moment. So Python's date time module, this is also very interesting. So this allows us to do mathematics with dates and times basically. So I'll show you a quick example. So start is going to be our start date, so that's date time dot date. So this is a date object, and it needs three parameters: year, as we can see, year, month, and day. So we put in 1901, January, and first of the month. So that's the start date. The end date is 2000. I think it's the 31st of December. There we go. And we can do all sorts of things with this. So let's say I would like to know what day of the week was 1st of January 1901. So I could do something like this. Because start is a date object, it will have all the date functions and we can use them. So start dot, here's a choice. Now I'm going to choose something weekday down here, weekday. This will tell us what day of the week it was, and I'll even let you see the output, which is here. Excuse me a second. Okay, so let's run this code, and we can see that it's output the number 1. And this means that the 1st of January 1901 was a Tuesday, because it starts with 0 for Monday, 1 for Tuesday, and goes through to 6 for Sunday. Okay, so Sunday is 6, that's important. We can do the same thing for the end, and then enter that. And that was a Sunday because that's given us 6. So that's a kind of a cool thing you can do. Of course, end, the dates are split into year, month, and day, so you can just return those variables. So end dot month should produce the number 12. Yes, indeed. And another cool thing you can do is get the number of days between two dates. So, oh, it's crashed. Well, let's wait for it to uncrash and then we'll continue. Okay, so it shut the bed for a couple of seconds, but it's back to normal now. Excuse me. So, what was I doing? Oh yes, we want to know the difference, the number of days between two dates. So, how are we going to do that? So, we need to do end minus start dot days. Now, how many days were there in the 20th century? There was 365 days times 100 years plus leap days, so that's going to be 36,525. Oh, 36,524. Okay, so how this algorithm is going to work, I might have explained this already, but basically we're going to go through every day in the 21st century. We're going to see if it was a Sunday, was it the first of the month, and if it was, we add it to a total. So let's crack on with that. Let's build the generator first. So we declare it as a normal function to start with. Def date range start and end. Start and end are the parameters. So we're feeding into date objects. For n in range, now how many times are we going to iterate here? Well, it's going to be the number of days between the start and end, so it's basically this. But we need to return this as an integer. Sorry, we need to convert this into an integer, so int and all that. And we don't need that anymore. So in a normal function you would use the keyword return, and then wherever it hits a return keyword, it just spits out whatever it's got. We're going to use the keyword yield, and that will tell the function, well, we're not quite done yet, we're going to visit you again soon. So yield and start plus date time dot time delta n. This basically yields the date. It's going to yield a date object which is n days from the start. So we'll start with 0 days from the start, 1st of January, 1 day from the start, 2nd of January, I failed at counting to 2, that's pathetic. So then it goes to 2 days from the start, which is 3rd of January, 3 days, 4th of January, and so on and so forth. I think you got the idea about 5 minutes ago. Anyway, that is the generator. So now total equals 0, so we're going to total up the number of Sundays that were the first of the month, and now we're going to do a loop. So for single date in date range, and then we define the start and end points, so start and end. And we're just going to loop through them all. So if single date, so single date is going to be a date object, so we've got all the functions at our disposal. So we want to know if it was the Sunday, which we said was the 6th day of the week. Of course it's 0 indexed, so 6th day of the week. Monday being the 0th day of the week. That doesn't make sense, but that's the way Python does it. It also has to be the first day of the month, so single date dot day is equal to 1. So if it's both of those, then we total plus equals 1, and then right at the end we print off the total. So normally I would hide the output panel at this stage because I don't want you seeing the answer, but once I've shown you the elegant solution, you pretty much got the answer anyway. So I'm just going to run this and see what happens, and that is indeed the correct answer. So now for the elegant solution. Now it's pretty obvious that in 100 years there are going to be 1200 months, and there are only 7 days that the first day of the month could possibly be, and in 1000 months one can assume that there's going to be a pretty equal distribution. So that is all you really needed. 1200 divided by 7, which gives exactly the same answer. So that is problem number 19. And thank you very much for watching, and I'll see you next time for problem 21.